So if I could ask the panelists and our panel moderator to come up.
So welcome to the panel. I'm Tim. I will be moderating / trolling these four up here, or at least managing you guys troll them. What we'll do, how we're going to run this, first we'll let them go do a brief introduction themselves. We'll give some discussion topics. I might prod with a few questions if need be. Feel free to raise your hand, ask questions, bring up new discussion topics. I'll call you out and you can ask a question. We won't obviously have constantly people doing that because we want them to talk also, but that's how we'll run this. So we'll be a little loose on that. So why don't you guys go ahead and start, introduce yourselves. Also, the topic of this is using GNU Radio in the real world. So that alone is a discussion topic of what real world means. I'll limit it and say my thoughts on that would be anything above the line of using GNU Radio for prototyping. So again, you can argue about that too, but I think that's drawing that line is a more interesting discussion, and discussing how to use it, past that line, out in the commercial world, trying to make money, trying to use it in industry for various things. So with that, go ahead.
Now it's on. All right. I'm Michael Osmond, and I'm the founder of Great Scott Gadgets and the designer of HackRF1, which is a software-defined radio platform, an open-source hardware platform for software-defined radio. And I got into SDR because I was doing wireless communication security research, actually just right down the road at the Boulder Labs at the time. And that's when I started learning SDR and found software-defined radio to be extremely valuable in the field of security research because I could take, for example, I could take theoretical vulnerabilities that I found in a radio system and actually implement a practical attack and a demonstration. I could turn theoretical vulnerabilities into practical demonstratable vulnerabilities, and that was extremely valuable to me as a security researcher. And so kind of my real world expertise, I guess, in application of GNU Radio is how it gets used in the field of information security and wireless security research in particular.
So I'm Tom Rondo. I am a program manager at DARPA and the Microsystems Technology Office. You most here will probably know me better as the guy who ran GNU Radio for the last 5 years. So for up until this conference, I was actually running the conferences, the last 5 of them. Really happy to be on the other side of it and actually enjoying myself this time because it is, you don't have even understand how much work it is, and Ben is handling it incredibly well. So. But that's where I come from. So I've been running this program, running it for 5 years. Before that, I used it for, I don't know what, 6, 7 years before then. So way back into my PhD, graduate school PhD days, using GNU Radio, trying to take, same as what Mike was saying, trying to take our ideas into the real world. Not just basing on simulation, not just basing on models and concepts just within a computer model, but actually taking those ideas, getting them over the air, seeing what happens when you get signals over the air, the impairments of the hardware, the impairments of the channels, real world things happening to your signal. That was always my interest, is in how we can actually, really the interest is how you can use software to impact what happens in the real world. I find that fascinating. I think it's really cool. And for me, the electromagnetic spectrum is by far the best way to actually to do that. The coolest, most interesting, most novel way of how we can actually control things in the real world through software. So that's really kind of the philosophical motivation behind my interest in this. And then from there, GNU Radio became the only obvious way to really do that with any practicality. The creativity, the sharing, the community that builds around it, as you all know since you're here for this conference. All those things trying to come into why I think that this is a great platform and a great way to do technology, innovation, science, and possibly even art in the future. I'm just kind of all over the place when it comes to where we can actually take this this kind of concept with all of the great minds and energy that that this group brings to the field.
I'm Dan Jacob. I've spent the last 11 years building small satellites for commercial industry. And in October, I joined a new space startup called Hawkeye 360 as Director of Space Systems. I started using GNU Radio probably right around the first GNU Radio conference, maybe a few years before that. And primarily, it's really important for the space industry and for aerospace in general because with spacecraft, the two most common failure modes are power and communications. And the traditional way that you're communicating with your spacecraft, which wireless is the only way you can communicate with your spacecraft, there's no wire, that's right, has traditionally been black boxes. And aerospace engineers are taught the fundamentals of communication systems, but then they're never afforded the opportunity really to apply them. And so when we were putting together a new space system, a new set of satellites where we had to develop a new downlink, we were looking to GNU Radio as a way to rapidly prototype that system and then deploy it in the field. And that was a huge success, and then we were able to apply that to command and control systems as well. And it really gave people who had some background in the communications theory, but not necessarily the chops to build their own radio from components. It really allowed them to dig down into the details and ultimately build a system that was even better than the black box that we were using before, and in a much more flexible manner.
My name is Martin Braun. I work for Addis Research now, involved in software development, RF-NOC development, and I do use GNU Radio for my day job for hardware testing, stuff like that. But the reason I'm on this panel is before I joined Addis, I was with KIT Germany, like those guys over there. And actually, I think this might, I think my 10-year anniversary in using GNU Radio is might be this year or next year. So I was young undergrad. I was into radio. I just couldn't figure out those those high frequency electronics. Different class comes along, professor tells me about software radio. I'm like, oh yeah. So if I do it in software, then this all becomes very easy, right? Because I don't have to deal with the electronics anymore. Turns out that's not actually true. But I learned that so much down the line, at that point I didn't have a choice. So I used it as an undergrad, but then as a PhD candidate and also as a teacher and a researcher, I use GNU Radio in various settings for teaching and research. Teaching in particular was very interesting because you can always open up the box and look what's inside. I mean, a lot of commercial suppliers are trying to put their platform into universities, and that's all good. But at some point, you're sort of hiding away the details from students, which are actually very interesting. Sorry, of course, this had to happen while I was talking. Yeah, but I'm gonna get into that later, and so I don't want to stop talking now.
And sorry, for those of you who can't see, if you want to look, Martin is so hardcore into GNU Radio, even his glasses frames are the colors of the GNU Radio logo.
Yes, that was the whole reason I decided.
All right. Well, obviously we have a wide background experience here. We'll get into the topics of the panel. We'll start with obviously the GNU Radio community is growing. Every year. Just the conference grows by a significant amount. I think this year there's 50 or 60 more than there was back in DC. So clearly there are more people getting into it, more people using it, which could loosely translate to more use in the real world. So I guess the first discussion, I'll say you guys already got this email, so hopefully you've thought about this already, and there won't be boring answers. But what's it going to take, or why hasn't it yet really caught on in, say, the bigger commercial world? There's a lot of small startup companies using this, but why isn't Google here, presenting? Why isn't Facebook here presenting? What are these guys? Or maybe they're using it, and maybe it's a licensing issue. I don't know. What reasons are? What would it take for the big guys to get involved?
All right, well, I'll start off then, because I think I have an interesting perspective on this, because having run the program for 5 years, I should have interfaced with all the people that were using GNU Radio, and every year we had this conference, and I got to know everybody who came to that conference. I had my own consulting business, so I'd integrate, or interact with people that way. I had no idea how big the program was. When I got to DARPA, everybody at DARPA knew what GNU Radio was. Everybody was excited that I was there because of my GNU Radio background. Every performer that I talked to, now, it's weird when you're at DARPA, everybody tells you what you want to hear. But I did talk, every performer that I talked to, every performer that even isn't, trying to get funding from DARPA, tells me that they're using GNU Radio in their daily lives and their work. Their research is dependent on it, their prototyping is dependent on it. So it was really gratifying, kind of on the other side of this, just to see how important it actually was and how many people were really using it.
Are they writing this into DARPA proposals, or requirements for their people, or are they just saying, oh, they chose it naturally?
So far, it's just that they've chosen it, yeah. So they haven't, actually, no, you will see them, I have seen it coming through in actual proposals coming into DARPA. And so they certainly will, obviously, when they start proposing to me, I'm sure, because, again, they're going to tell me what I want to hear, but I'm fine with that. But no, so like I said, it was really gratifying to see how big it actually was, bigger than I really even understood while I was kind of on the front lines of getting the program to where I thought it was, where I wanted to take it technically and from a community base, which is now the guys here, Ben, and everybody is taking that to the next level. So I really see that they are already using it. Now, there is a question of what is the real world and what that means. So most of the people that are using it are really in that research, development, and prototyping phase. To me, that is a perfectly valid use of a program like GNU Radio. I think that is to an extent the real world. On the other hand, I get what Tim's saying about what it would take to get us, why isn't it actually being used out in literally boxes, usurps, hackerafs, RTLs, they're actually out there inboxing the real world. And there are. But why aren't there more? Why aren't we seeing them more? To me, one of the problems is that GNU Radio is actually too powerful for most of those applications, in the sense that it's too flexible, right? The flexibility comes at a cost. The flexibility allows you to develop and hone your application. When that application is ready and solidified, you don't need GNU Radio anymore. And I think that, and really GNU Radio in some senses is almost getting in your way. There's a lot of overhead in that schedule that allows for that flexibility. So to me, it's when you start to identify when that flexibility is required in those real world settings is when you're going to start seeing it roll out. Right now, those point-to-point, or those point solutions, I should say, not point-to-point, but point solutions, they're too specific. They're too, you have to harden them, you have to make them efficient, fast, maybe power as a consumption, and then there's, let's see, what was the other? Oh, and then if you're doing LTE, well, buy an LTE chip, right? Standards are in some senses boring because, they're there, they're done, just buy the chip, buy the Wi-Fi chip. So for those kinds of communication links, just kind of go that way. Where is the flexibility? Where is that adaptation that a thing like GNU Radio allows you to do? That's where the field stuff comes in.
So I want to take your question literally, because you didn't say why aren't they using it, you said why aren't they presenting? And I don't have a good answer for that, because the part of what Tom said is definitely true. There's a lot of people that are using GNU Radio and they don't advertise it. And I'm sure there's a lot of people in this room who could name one or two groups, government or commercial. So why aren't they presenting? I don't really have a good idea. I think it's because the people, so this is a wild theory, wild guess, but I think the people who are using GNU Radio, they're just, some engineers told, do something, prototype, and he goes, well, I guess I'm going to use that. And then it never sort of comes out of that stage where it's used as a very useful tool because people aren't working on GNU Radio, they're working on a prototype, so maybe they'll go to some other conference and say, oh, we did this thing, it's wireless, and then the fact that they use GNU Radio for them is as uninteresting as the fact that they used screwdrivers and coax cables, and they don't go to coax cable conferences. I don't know if that's actually the reason, but I do feel there's a bit of a disconnect between the number of people that use it and for what they use it. There's some really cool projects in there, and the people who then advertise it and come to conferences like this.
I really agree with what Martin said about, I think there's a lot more people out there that's using it that don't necessarily want to advertise it. I had that same experience with the company I worked at before. In the end, we were much more open about it, but there's a lot of anxiety in commercial companies and probably even in the government about advertising what you're using, because there's some perception that may reveal some advantage that you have that somebody else then can take advantage can pick up on. I also have seen a little bit of a culture of not invented here. So there's some groups that use something else as opposed to GNU Radio, and the reasons for doing that may not be necessarily sound. In some cases they are very sound, but in a lot of cases it's just we've been doing what we've been doing, and we're gonna keep doing it that way, and we don't want to go with GNU Radio. Another thing I think is just exposure, right? Students are, almost certain, engineering students at least, are almost certainly exposed to MATLAB and LabVIEW, and a lot of them are going to be using these tools for similar things that they would be doing in GNU Radio. Now there's a lot of people who then go on into industry and they're exposed to free open source software, and their natural inclination is to go find new projects that might suit some new need that they have, right? And they'll go out and look. But I think a lot of people have just they've been exposed to MATLAB, they've been exposed to LabVIEW, they've been building all their software based on that. And there's a lot of inertia just to keep doing it that way. I mean, myself, it took me a long time to go away from MATLAB to Python, for instance. But now I can't imagine, ever using MATLAB again. Luckily, I didn't have that much experience with software radio before GNU Radio, so that was my first exposure to it.
Well, I agree with all these guys, but I'll just share an anecdote from my early experiences with GNU Radio and trying to get something into the real world. One of the first projects that I got interested in that at least that I was able to publish was Bluetooth sniffing, and I found a paper online written by Dominic Spill, who happens to be sitting over at our booth right now. And he had implemented a rudimentary Bluetooth sniffer with GNU Radio. And I said, that's really cool. I want to do that. And I downloaded his code and I started working on it. And I quickly found ways that I could improve it. And I started collaborating with Dominic remotely. And we eventually published some work. And we published a way to do Bluetooth sniffing that people hadn't been able to do before. And we presented this solution at a conference in the InfoSec community. And we said, here, buy this user, but not the one you can afford, but like the higher end one, and then take a soldering iron to it. And here's a patch for the FPGA. And then you have to download GNU Radio and compile it. And this was non-trivial back then. And it was, we presented this what we thought was this great solution for sniffing Bluetooth, and nobody ever used it. Go figure. And then over time, I started realizing, hey, nobody's really using this work that we did. Maybe we should try to make it more accessible. And the way that I made it more accessible was by making a $100 Bluetooth sniffing dongle that was not software-defined radio. It was using an off-the-shelf wireless transceiver chip that has like a digital modem on a chip. That was kind of a special purpose, low cost way to implement what we had prototyped essentially in GNU Radio. And so I just want to kind of add to everything that these guys have said and say that cost matters in a lot of cases. We have Bluetooth sniffing is now a part of the information security professionals toolkit, and it didn't used to be. And the reason it is because we were able to make a $100 device that does that task instead of a hard-to-use $2,000 device that does that for that particular application. It was hard to use. And
how is it hard to use?
Well, just because you had to take a soldering iron to your user, right? Like, not a lot of people want to buy, $1,000, $2,000 piece of equipment and take a soldering iron to it, right? So it was just an accessibility thing, and cost, I think, had a lot to do with that accessibility, and the economics of SDR are interesting to me. Like, in the long distant future, I think that all radios will be software-defined radios. But we're still a long way from that. it is way more affordable for most types of radio systems, especially simpler types of radio systems. It's way more affordable to use non-SDR approaches.
So that brings up another good topic related to low-cost SDRs. So how much, certainly cost plays into it. So how much have you guys seen in the real world, again, does the actual RF performance play into it? Because obviously if you're going to lower the cost, you're trading off something for that. Usually it's some sort of RF performance. I mean, in your case, obviously you could still do Bluetooth sniffing, using those, because it's it's not an SDR chip in that case, right?
Yeah, so I have a completely different perspective on this, probably, like, compared to Dan, right? We're gonna be on opposite ends of the spectrum because, like, for me, in the information security community, like, I'm interested in, like, detecting the Bluetooth devices that are in this building, and that's like the most, and 90% of the things I want to do are just like across a table or across a room, or hey, what's that device in the corner? Let's figure out what that is. And RF performance for the most part doesn't really matter. So I just have to get a base threshold where something works, and I'm functional to the point where I can experiment with higher layers of the protocol, and that's it. I usually don't care about how optimal my antenna is, even.
So I'm actually going to surprise you probably, because I would say in my previous life, I found that I primarily used Edis products, but I think other products would have worked as well. I actually found them to work perfectly fine for satellite applications. Now, you definitely have to think about what you put ahead of that. You have to, consider that you need an LNA, you need a properly designed antenna, you need a filter, you need RF switching, and you need to think about how far your cable length goes, and all these types of things. But ultimately, at the end of that was an Edis SDR, and those worked perfectly fine for our application. Now, I was both blessed and cursed to work with a lot of RF engineers who knew a lot more than I did, and I actually learned a lot from them. But they also were typically mostly superhet guys, and so when they looked at these designs that were working down, at designs like the Edis usurp, they were seeing things that they inferred as, I guess Matt gave a talk on the things you can see in the real world with software-defined radios, and these guys were seeing things like spurs and all sorts of stuff that were really just user error. It's like, I'm compressing the waveform by applying too much gain or some other thing, and when you actually use the device properly, it wasn't an issue. Now, in my new job, we are a RF geolocation company, and I won't get into a whole lot of details about that right now, but from an RF perspective, the performance is we have a more demanding requirement on the RF performance, but we have a much higher requirement on timing. Where we're requiring, things that are in the order of nanosecond timing accuracy, and that is where we're pushing the bounds of the hardware. But we're still able to do pretty amazing things with off-the-shelf hardware. So we're getting to the bounds of what's possible with $1,000 SDR, but we haven't hit it yet.
But still using GNU Radio, for this stuff.
Still using GNU Radio. GNU Radio has not been a limitation in any way so far. Yeah. So,
we have some pretty good products RF-wise, but I don't want to advertise those here. The one trade-off that you mentioned in your talk was the cost trade-off. Like when you want to get really good RF, then the price skyrockets. But I don't think it actually matters that much for the popularity of software radio or any specific software radio framework. I think the initial reaction and the popularity of a framework will depend more on like the software usability and like how well can I integrate that into my whatever I'm doing. And I think by the time you're arguing about like dBs of dynamic range, etc., you're so far down the road that you've already committed to something. And then at that point, it's about, well, I'm just going to upgrade this daughter board to the next better one, for example. But if you get frustrated and caught up on like the simple initial tasks, and at the beginning of any RF-related task where you're using software already, you probably won't need that fantastic RF performance. At that point, you just want it to work. You want to get the software installed quickly. You want to get the APIs figured out, and you want to
good documentation. Right?
Yeah, like the fantastic documentation that GNU Radio now has.
So to address the point of the documentation, it turns out that most of the people who complain about documentation don't want documentation, they want examples. I think that's really what we were lacking in GNU Radio for a long time, is enough examples so that you asked a question and you saw how you could use that block to get your thing done. We had a ton of documentation that was you just wouldn't want to read it. But to the question, I really like linear time invariant systems. So as long as you're coming in through that radio system and that signal that you get out there is LTI that has no nonlinearities in it, we can do whatever processing you want to do on that thing from a computational perspective, just numerical processing. So much of the math we can do as long as it's a linear signal. So that's really my criteria, is how to get that signal into your system as a linear signal. So if you can see the signal above the noise floor, and you're not up here clipping and hitting all those harmonic generators that Matt was telling us about before, everything in between there we can handle. Now, to handle that, we may have to throw a lot more math at the problem, but that's the fun part. And that's where I think GNU Radio really starts to shine, is in the ability to think about that problem, that math problem, play with different ideas in that space, maybe even rethink how we handle our signal processing in different areas, things that we might not have classically done, but because we have this capability to just play around here, we can start developing some really cool new ideas. So I think once we start thinking in that perspective, things start to become illuminated. And I'll take that illumination concept a little bit further. So talk about expensive things that you don't want to hack. Take your phone, your cell phone, chop it in half, and get the cross section of the lens on your cell phone. It's an interesting cross section. It's actually a Fresnel lens. That Fresnel lens is used to capture as much light as possible to hit the CCD detector. But by using a Fresnel lens, you distort the image that's coming in here. Except it's a lens, it's a fixed thing. So we fix that up in software. So we're just doing a linear distortion on the image. We can actually equalize that and fix it up in the software. And you can see how the amazing things, the amazing images that are possible with something like this. Of course, now it's that dynamic range issue really does come into play here. So I'm not going to go any farther on this, but the dynamic range will explain to you where your radio can be used. And my new role with the Defense Department, we're talking about some serious amount of dBs being generated from some of our systems and therefore being received by our systems. That linearity problem becomes exacerbated at something like my cell phone camera is not going to handle that kind of dynamic range that I have to deal with. But as long as you're in there, we can just apply math to it.
Anybody have any questions on this topic for these guys? Do we have a mic out there still? Actually, yeah, can the mic bring the mic? Bad joke.
How do you guys feel the trade-off right now of GNU Radio being used for simulation versus people thinking GNU Radio must be used with some hardware? Do you think we can push the pure simulation GNU Radio, or should we more? And maybe get that as a way to get it out in the community and get more interest?
I'm going to keep this one really short. I look at it as just, it's a continuum. And I give a talk where I show, if you're trying to get an idea, put in GNU Radio, get it over the air, first time you're going to do that, you're going to fail, and you're not going to have any idea how you fail. So you really do want to start with that simulation. But what I like about GNU Radio is that simulation starts with maybe a file source, ends with maybe a file sync. You do some analysis on that. You start to put your blocks together, and by the time you're done, you take out that sync, you put in a usurp or an Osmo SDR sync, and all of a sudden you're over the air. So I think the continuum of going from simulation to over the air in this particular concept has always been one of its major strengths for me.
I would like people to not make that distinction at all. Because you can throw down a channel block, or whatever we call a channel model block, and then that's your channel. Or you actually throw down the user block, and then that's your channel. And then you have to figure out the different kinds of degradations, but that's it. And then the interesting part is not like if you're working in GNU Radio, the interesting part is not going to be the hardware controls, because they abstracted away. So you want to work on the modems, etc. You shouldn't care about is this simulation or Ben actually had a slide on that where he's like, you can just flip a switch and it's one or the other. And I think that's exactly the right mindset. You don't go through these phases. It's basically what Tom said.
From my perspective, in my experience, what I've seen, especially, I focus a lot on education, and I try to teach people SDR, especially in the InfoSec community. I've been trying for years to get more people aware of this amazing tool, and how it can help them in InfoSec. And as I teach people software-defined radio, and I see people learning about software-defined radio, the distinction between simulation and over-the-air blurs over time, but is really sharp at first. Somebody who has a little bit of experience under their belt doing SDR stuff will say, oh, I can simulate that, and it's just as good as if I did it over the air. But when they're new to the field, nothing beats the over-the-air experience. Like when you actually capture a signal from your garage door opener remote and replay it, and your door opens. Like that real-world experience is so exciting and gets people motivated to learn more. So I think in an educational context, there's a really important use for over-the-air activities, especially early on. And then later on, once they're used to it, once they've gotten convinced that they can do over-the-air things, then they're like, oh, I can just simulate this, and it's fine.
So I would disagree with just simulating and it's fine, because our channel models are so awful that there's no way that we can really prove to ourselves that because it worked with a 3GPP published channel model that it's going to work in any real scenario. So I still think that, I think you're okay in that, yes, we can actually parameterize our simulations better and have a better understanding of what they mean for us, but I don't think that you're ever going to get far enough in that space to really get there. Now, the other thing that I do want to say is, coming from my experience trying to do really advanced stuff with signal processing and software radio, and then I would see people go up, buy an RTL SDR or a HackRF or even a USERP, they plug it in the first time, they run through the FM receiver example, and they're receiving broadcast FM, and they get super excited about it, and they're just like jumping up and down, they're super excited, oh my god, look at this, what I've done, and the snarky part of me, which is a large part of my brain, was thinking, well, yeah, you just built a $3,000 FM receiver. Taking a step back from that and going, yeah, but they did it themselves, right? They saw the signal from the antenna base of the antenna all the way through to where it came out as audio. And that is a revelation to really get that control over. To me, it's control over the electromagnetic spectrum, which is a really, I've said this before in public presentations like this. What we're doing here is controlling the electromagnetic spectrum. That is one of the 4 fundamental forces of the universe. How is that not incredibly cool? And to actually see that happen from something that's being broadcast from somewhere else, invisible to you, coming through to an audio signal that you can hear and manipulate, that is an incredible amount of power that, yes, you can just buy an FM receiver off the street, but you don't have that's going on with that. That's what launches that excitement into the next level of doing this kind of work.
Yep, over there.
So earlier today we saw a slide in the keynote that showed the Google Trend searches for the term software-defined radio. And I noticed that we appear to have peaked that curve in about 2013, and it's actually on the ride back down. In contrast, this group gets bigger and bigger every year. So I'm wondering what your thoughts are as to what might explain that discrepancy.
So I'm going to steal this. I was just at LinuxCon, and Jim Zemlin put this up. I think it was Jim that put this up there, but it's the old Mahatma Gandhi quote, right? First they laugh at you, then they ignore you, then they fight you, and then you win. And I think we've won. I think software radio is now the de facto way of doing research in electromagnetics. So comms, radar, electronic warfare, all the stuff that we do. This is where it all starts. It's where it all ends. We talk about when will SDR take over. I mean, it already has. The cell phone baseband processor, I argue, is a software-defined radio. It's not the flexible software-defined radio like we know in GNU Radio, but it is basically it's software that's running that thing. So I think that's the thing is like we really have just there's no need to talk about it as its own special thing. It's now just the way we do things.
I have an addition to that. So one thing I've observed is the content is very different. If you go back 10 years and you look at old SDR forum, it's more high level, and it's like people have to sort of convey the idea of the SDR in the first place. It's like, you don't have to do it in hardware, you can do software. And then at some point, people got it, like you said, but now we're at this point where we need to figure out how to actually efficiently implement all this stuff. And there's a lot of open questions, and this is a different crowd from 20 years ago. I assume I wasn't around. But like here we have very, very difficult questions to answer, like Nathan's work on like how to most efficiently do this processing in SIMD, or maybe SIMD is not even the right answer. Maybe we need something else entirely. The fact that there's a lot of smart people in this room and there's a lot of unanswered technical questions for GNU Radio that we have no answer for right now, like how to optimally schedule, is a good sign that like there's a lot of interesting actual R&D and technical stuff that needs to be solved. But on a high level, it doesn't really matter. It's all SDR, and it'll be a little bit faster or slower. So I think the focus has shifted, and that's why the conference has shifted. That's why GNU Radio conference is big now, and other conferences are small now, and or have even ceased to exist, like WSR.
All right.
One thing to add to that, we saw in the early 2000s, up until about, kind of following the trend of that curve, was also it was kind of a lagging the trend of the research dollars that were going after software radio. There's a lot of money being put into implementing software-defined radio, and most of that's fallen off, and well, we're still here and we're still growing. So basically everybody started to get back into, okay, we've done a lot of this research, we've proven a lot of this stuff, but GNU Radio is the way that we're implementing it now, and we're actually doing it now. So I think that's part of it too, is now the research dollars are in how to effectively use software radio to do cool stuff, but that software radio part of that is essentially an assumed part.
Yep.
Okay, so if you could not fail, where would you like to see SDRs used in the real world? Where would it be fun to see them?
I think it would be really interesting to see it used on more important satellites. I mean, today, even my entire use of SDR and GNU Radio has been on the ground. I can tell you that's going to change, but we're still in low Earth orbit. We're still dealing with, fairly narrow bandwidths and lower frequencies. I think it would be really interesting to see it applied to some of these spacecraft that are going further out, because as research into communications changes, there's the opportunity to upload new software to those spacecraft and to change how they're used or how much bandwidth we can get to them. Now, I mean, you're still fundamentally limited to physics and what Shannon says we can get, but I mean, you've seen how much software radio has changed and its use over the past 10 years. So you can imagine some of these spacecraft that have 20 years of useful life, and see how much extra utilization we could get out of them as they go to the outer solar system.
So if you say I can't fail, then it's easy. I'm just going to say everywhere, and I want it all to be open source. But I have a more specific answer for you, and I'd like to see more use of, and specifically open source software radio in the whole telecom business. So the telecom providers are pretty close up. Really, most other industries and researchers don't really care what they use, as long as it gives results. Telecom industry is tough. it would be nice if standards were like closer to code, for example. Like instead of being these long descriptions of, why not give some reference code that is open? I don't know how feasible that is overall, but I think it could go a long way.
What would that help with? I mean,
What would
more
it help us?
research? I mean, with that, if they're posting their.
So this
what
is
is
this
that gonna aid in? Yeah.
this is maybe the most important technical infrastructure of mankind. I'm not even trying to be trying to exaggerate here. There's like, if we take away wireless communication, like society as we know it right now would actually probably get a lot of stuff done, but it would go it would also go, things would fall apart.
I won't get my cat videos.
Yeah, things would fall apart, and this is very, very important stuff, and it's it's very tightly controlled and closed off, and yeah, I think that's a shame.
Yeah, I think it was amazing that, 1893 when Hertz proved radio waves initially, and by 1897, I want to say, the first Marconi patent was filed for wireless telegraphs. So it was that, and the joke about the Hertz thing is when he was asked what this is good for, he says, "I have no idea." And then within 4 years, it's the foundation of this billions and billions of dollar industry, and as Martin said, kind of the foundation of a lot of our culture and society.
So you asked what would be the benefit of better defined standards. I think it's interoperability, right?
Well,
So
it was the benefit of say Qualcomm posting all their IP. I mean, which effectively is what you're saying, right? And their source code for implementation of the base station.
Actually, that was not what I was saying.
Oh, okay.
So, businesses still need to make money, and I don't want to take that away from them. I was talking more about the standards bodies, and who are effectively the industry, right? But there's still a distinction. Like, if you want to sell the cheapest chips, there's still a lot of technical know-how you need, and that's how you beat your competitors. That doesn't mean that that people try and put a lot of secrecy in the whole telecommunication. I think that's not good. But maybe that's just the idealist speaking.
So what aren't they posting, I guess, the standards bodies that you want them to post?
Well, I mean, there are complete communication standards that are de facto inaccessible, like LoRa, for example, right? I mean, it's not exactly the same as LTE, but sorry? Yeah, I know. That's what I'm saying. I think it's pretty much not at all open. So, yeah. So that's one example.
On a related note, I think not only would it be great for standards to use SDR and open source SDR in particular, but also research. I mean, there's a lot. We've already talked about how SDR is the norm now in wireless research. Most wireless research is using SDR, but you wouldn't necessarily know it based on what's published. Because a lot of research isn't publishing source code, for example, and so kind of taking this Martin's spin on it to a little further is like not just SDR but open source SDR. I'd really, if I could see it anywhere, it would be in research papers publishing their full source code so that we can actually reproduce the work that people are calling science.
So I'm going to take the naive stance here. What if when a new wireless standard was created by one of these standards bodies plus all the commercial people in the background, what if that was implemented, the reference was implemented in GNU Radio or something like that, so that so when Qualcomm wants to come and implement this thing on a chip, they have to compare it to a working system and software, right? Because I see this all the time, in wireless systems, even in things as simple as AIS, where different manufacturers implement it differently, slightly differently. Most of the time it works the same, but maybe they interpreted something differently, or maybe some part of the standard was closed. And if you have an actual working thing that you compare to, I think that improves compatibility. And I think you see this borne out, and I think Michael was alluding to that, or I'm going to piggyback on what he was talking about with things like tools like the iPython notebook, where you can share reproducible research. So you can take a data set, you can analyze it, you can write a paper based on it, and then you can release all the code that was used to reproduce that result with the greater community, so people can look at that. They can see if there were problems, and then they can also build upon it. And I think it's basically the whole free open source software philosophy just applied to research or creating like a radio standard or something like that.
Got one there.
So I'm going to essentially say that I know nothing, but I have a couple of questions. And one is getting the power up on transmission, and maybe there's something already designed there. But once you get the power up, then you have a lot of people that have now been empowered where there was a technology issue or a economic issue. Now they can transmit on frequencies maybe they weren't supposed to. And now we have a bigger problem, like Mr. Seabar's listening to all of this data coming from airplanes. Well, what if somebody jams that, or worse, feeds in bad information back? And I don't think that's a good idea. I'm wondering what controls are needed, or if we don't want any controls at all. And so is the power coming up, and what controls once we have capability up there?
I primarily use SDR for in my professional life. I'm not a ham, so I'm not. I don't have a lot of experience with, our people applying a kilowatt transmitter or a kilowatt amplifier to their hack RF and trying to talk across the ocean. But I certainly do apply amplifiers to SDRs for talking to satellites, and as a professional, we try to adhere to the standards. We try to make sure, first and foremost, from the lowest level, we try to make sure the waveform is clean, so that when we put it through, hopefully a good RF amplifier, that we're not adding any distortion that we wouldn't already be expecting. And then, of course, you want to look at the amplifier design and make sure that's good, and put a filter on the outside of that. There probably is a danger that there are people that have access to that type of hardware, but don't necessarily have all that experience at in software radio, or in making sure that their hardware is clean. I personally haven't had too much trouble with that. Because I'll say it's been very important to me that people don't interfere with me, right? And I've typically operated in bands where there are other ham operators, and I haven't had any issues with that. But that's not to say that this isn't an issue down the road. But I'll tell you, I have a vested interest in the FCC not giving me a bunch of hassle with what I do. So I hope this doesn't turn into a problem, and I hope it doesn't become something that requires more regulation, because I think it would just hurt everyone equally.
A few years ago, I met a fellow at a hacker convention, and he asked me if I had any opinions about ethics of how people use my products, and I told him, I think the hacker community is full of wonderful, upstanding citizens who are doing great things that excite me all the time, and that there may be a few bad eggs here and there, but I have to be comfortable with the fact that things that I put out into the world, the open source designs and code and everything that I give away, could be used for good or for evil. And he looked at me with a funny look on his face, and he said, it's not good or evil. He said, your stuff can be used for good or for awesome. And so I kind of think of that a lot. People could be doing good, or they could be doing awesome. But from my perspective, I'm teaching a lot of people about SDR and getting them into using new equipment and new techniques, and oftentimes the question comes up like, hey, can I plug an amplifier into this thing? And usually, my answer is, you probably shouldn't if you have to ask. You can get away with a lot at extremely low power and not be a bad neighbor on the spectrum. But I really stress to people that they should try to be good neighbors of this on the spectrum, because we all have to share it. And regardless of how it's regulated and regardless of what country you live in, you know, it's a shared resource and we all have to get along on it one way or another. And overall, I haven't really seen a problem. And like, people have been running various types of radio equipment with amplifiers, you know, in their garages for decades, and I don't think that's really been a problem. So I feel like the community is capable of exhibiting restraint and capable of being good neighbors on the spectrum.
I think a good sign for that is the fact that lots of people are getting call signs, getting their ham licenses. And as soon as you've taken that step, that shows you take a certain amount of responsibility. And I don't want to sort of say we shouldn't think about this, because you're right, there could be a problem, but this is something that happens for any kind of community that makes access to technology easier. You know, we had the 3D printing guns, so do we want to ban 3D printers? Probably not. And there's probably many other examples.
Drones.
There we go, drones. Yeah. I think the SDR community has been, like you said, has been pretty good about it, and I think conferences like this, that emphasize that.
Yeah, I tend to agree with both those. That I think most people who are doing this stuff are doing it for the joy of it, for the just the exploration of it, or for an actual business opportunity that arises from it. You know, we talk about hacking the spectrum, and then there's this concern. Okay, well, all right, if we're going to hack the spectrum, if we're going to break into these systems, if we're going to jam something like that, you know, that there may be these Dirk, your RF script kiddies. Let's talk about that, you know. So we have these script kiddie and they'll cause some havoc and they'll cause some damage. But what's the financial motivation for them to do that? So until we can identify that, like, that's really where the hacking took off in the internet generally, was when they found a financial incentive to do that, besides from just causing a little bit of hassle. There are some nightmare scenarios though, right? And that's the kind of state-sponsored terrorism. Is we do have to be aware that there is stuff, that there is, you know, things out there. We had that conference actually just in Boulder 2 months ago, ISAR, the International Symposium on Advanced Radio Technologies, and that was some of these were brought up there. It's that ISAR conference does span the policy and technology groups quite a bit, which is great for that. And so that, you know, there was things like, what if you have an active shooter scenario and somebody jams the first responders' comms? The amount of added mayhem that causes. Luckily, that's a minor case, but B, that's also, you know, it's one of those things where you imagine, well, they're going to do that anyways when they, you know, kind of get to that point. The technology that we're doing here may enable that faster than it would come. But at the flip side of that is, if we are developing the technology that we're also creating a space to make more robust communication systems, so that we can actually combat those scenarios when they happen. My feeling is that what we've been doing, what most technology does, is it just raises society up to be better in general, with a few bad corner cases that can happen. But if everybody else is being raised up, we can actually be more prepared about this. I will close by saying, hopefully you're going to be at the rest of the conference, because I'll plug Pierre DeVries' talk. What is it called? FCC, friend or foe, SDR, trick or treat, or maybe flip that around. Pierre's an old friend, and he's a fantastic speaker, and he's thought a lot about these issues, and I think that's going to show up in his keynote. So be prepared to think more about that this week.
All right. Yep, go ahead.
Are you guys aware of GNU Radio making it through difficult certification scenarios, like, you know, when human lives are at risk? Does GNU Radio exist in any of that domain?
No. The answer, yeah, I don't know. I will say that the SEC has changed a lot of its policies about standardization or certification of SDRs, right? The famous case is VANU was in 2003, maybe 2005, when VANU got the first FCC certified software radio to be put into a commercial market. That's the first and only one. Everything after that has kind of been, well, it is actually software radio, but we're not going to call it that, so we don't have to go through these extra certification levels, stages that they put out there. They're actually going to, I think they're changing their policy on how to certify, the FCC, how to certify the SDR, basically coming from the perspective that everything is an SDR, so why should we treat it differently than anything else? That having been said, I don't know in particular of GNU Radio in that scenario.
Well, correct me if I'm wrong, but I think a lot of those certifications focus on the hardware and not necessarily the software that's running behind it. I mean, it's the RF spurs and things come out of it. Got one over there. Oh, what we got? Go ahead.
All right, keeping in mind this is a new user day and we're talking about real systems, so I've received some signal, I've decoded it, maybe I have some bits out. What now?
Ask Ballant.
Actually, no, that's an interesting point, because most of the people that I think we traditionally interface with, like if you go to some of the other open source or hacker conferences, DEF CON, I think TorCon, a lot of the Usenix people, when they're challenged to get into this space, the wireless space, they're working on the 82.11 packet, right? That's their vision of the wireless world. So everything before that is still magic to them. So it's a great, I'm going to spend a little bit more time thinking about that, but it's an interesting way to, I think a lot of people want those bits, so maybe it's like we're done and hand it off to the next community. Like, really what I think is there should probably be some more intersection between those communities, but I think that's where we're kind of are right now.
I get that question a lot from folks in the information security community, because we do a lot of reverse engineering of systems, and so people who are getting into SDR from that community are usually reverse engineering some kind of wireless system, and they will find the frequency and find a modulation and figure that stuff out and kind of get. It's a major triumph for them to get from this signal that's going over the air to bits. And once they get bits, they usually are like, oh, I understand what to do from here. Like, because they come from a background where they may understand like MAC layer protocols and above, and they understand like how to, for example, do differential analysis by XORing one packet against another packet and seeing what changes. And those kinds of techniques for dealing with higher layers of the protocol and doing that level of reverse engineering is kind of a more well-known, tried and true kind of technique, but it is a distinct point at which most people stop using GNU Radio and start using other tools, and that is something that is starting to change a little bit. There are some really cool things that have come up that have become available through GNU Radio, like message passing interfaces and stream tags and like Tim O'Shea's event stream stuff, and there are tools that are there now that didn't used to be, but they're tools that you can kind of build MAC layer stuff with, but aren't necessarily great for reverse engineering the MAC layer. And so I typically don't point people to those tools yet. If they're doing a reverse engineering process like this, I typically point people to a Python shell or a variety of other tools that can be used to kind of take those bits and analyze them.
I think to add on to that, what I'd say is we shouldn't be afraid to move outside of GNU Radio. There is a point where we should naturally transition to the upper layer. If we're talking about building a comm system, for instance, at some point, it's silly of us to think that we're going to implement TCP in GNU Radio. Why don't you? That's when you put that tap device block into the GNU Radio flow graph, push that out into the Linux stack that already managed that type of stuff. Marcus is making furious gestures back there. I'm really curious what's going on here. It's Marcus Mueller, who's our muse on the GNU Radio mailing list, by the way. If you've ever needed a question answered, he's answered it for you. So I'm really curious what that was about. But I think that you do want to eventually move out of there. Maybe like, GNU Radio, we can start handling some of the Mac stuff more than we are, because there really isn't an open source version of Mac protocols that anybody's really produced, or that at least that I know of that's really out there and big. So handle a little bit of that, and then once you're at the network layer, I think you should move out. Or once you're at some layer, there is a reason to move out into other worlds. We don't have to tackle everything inside of GNU Radio.
All right, well, we'll have to wrap it up there. Let's give our panel a hand. Thank you, guys.